I would like to welcome everyone to the webinar prepared by the Noise Control Building Materials Marker Group at Kinetics Noise Control. This marker group specializes in floors, ceilings, and walls. My name is David King, and I will be the presenter for this webinar. My role within the marker group is project coordinator. I work alongside the Kinetics rep to produce shop drawings for the specific products or the projects. Here at Kinetics Noise Control, we do appreciate feedback on how we can better serve you and your project. If there is something that we touch on here or another subject in general that you would like a deeper, in-depth presentation on, please let us know. If for any reason you've missed a section of the presentation, please visit our website after the presentations have been completed. There you can find a live recorded version of this presentation for you to review and revisit. After the presentation, I will be available for one-on-one sessions to specifically address your questions if needed. To schedule your session, please email me at dking, K-I-N-G, at kineticsnoise.com. In today's presentation, we will be covering and discussing reading and understanding the KIP charts. The topic and sections we are going to cover are identifying and recognizing the KIP labels, review KIP loading ranges, determine static deflection, and natural frequency. So what is a KIP isolator? Here you can see the definition and an explanation of the KIP isolator. First, we must be able to recognize and understand the labeling of a KIP isolator. KIPs are identified by their size and glass density. Usually you will see two numbers, then a letter, followed by another number. The first two numbers, underlined in blue, refer to the length and width of the isolator in inches. The letter refers to the density of the glass. This chart shows the minimum and maximum load per glass density. Our charts show minimum and maximum loads in relations to PSI, or pounds per square inch. These charts measure in pounds per square inch for the KIP isolator can come in different lengths and widths, as well as heights. The two factors determining the load capacity of an isolator is the surface area and glass density. For example, a 2-inch by 2-inch cube can support a maximum of 400 pounds, while a 2-inch by 2-inch L can support a maximum of 200 pounds. Also, a 3-inch by 3-inch cube can support 900 pounds, as well as a 6-inch by 6-inch G. While one is smaller than the other, but due to the glass density, they can support the same amount. The last number refers to the height of the KIP isolator. Please know that a KIP isolator cannot be taller than it is wider. For example, a 22 Q3 is not possible. If there is not a final number, such as 22Q, this means that the KIP isolator is 1 inch tall. Again, if you have any questions about identifying a KIP isolator, please feel free to email me at dking@kineticsnoise.com. The first sheet we are going to look at is the S-21.00-1A. This is our KIP data chart, which can be found on our website. For this webinar and presentation, we are going to focus on the highlighted section, which covers some of the L isolator series. It is important to remember from the previous chart that the min and max for the L glass density is 10 psi to 50 psi. In this column, we have the model names, which should look familiar from the previous section of identifying a KIP isolator. Next is the loading range in pounds and kilograms, static deflection range in inches as well as millimeters. We have the natural frequency range, and then we have the dimensions. A and B refer to the length and width of the isolator, also in millimeters. And C refers to the height of the KIP isolator, in inches as well as millimeters. Let's first look at the model KIP 22L. As covered in the previous section, the first two letters refer to the length and width. As we can see in columns A and B, reflect 2 inches. And there is no number after the L, which means that the isolator is 1 inch tall. As you can see on the next model, the height is 1.5. And we can see in the column C of 1.5 inch tall. Here is one example of how KIPs can come in different lengths, widths, and heights. But remember, the isolator cannot be taller than wider. Let's check out the loading range. Here we can see that the first 3 models share the same loading range. And that is because the surface area and glass density are the same. They all share 4 square inches that are 2 by 2. Remembering that the min and maximum load is 10 psi to 50 psi. And that is why we see a range of 40 pounds to 200 pounds. Though these 3 models share the same surface area, their heights are all different. This explains why the deflection ranges are all different, as well as the natural frequencies. Let's quickly review the next 3 models and test our knowledge so far. I would like to point out in this relationship, which can lead into our next chart that we will review. Seeing a 90 minimum to a 450 maximum is due to a 3 by 3 surface area, remembering that there is a minimum of 10 to 50 psi. We can double check over in the A and B that it is 3 by 3. Now let's check out the static deflection range of a 1 inch KIP isolator for the 22L. It's 0.13 to 0.27. And now the deflection range for a 2 inch is 0.27 and 0.54. This is because of the height of the isolator affects the percentage of the deflection and natural frequency range. For example, a 1 inch KIP deflects 0.13 to 0.27, which is 13% to 27% of the undeflected height. The 2 inch KIP deflects 0.37 and 0.54, which is still 13 to 27% of the undeflected height of 2 inches. As we can see that 1 times 13% is 0.13, and 2 times 13% is 0.26. Yes, 13% of 2 is 0.26 and not 0.27, as stated in the charts. This is due to rounding of the results for the results to be easily read. Again, if you have any questions covering the previous chart, please feel free to email me and I will be happy to address them. Now we are going to look at sheet FF.210 and how the information here relates to the information on the previous document. I've copied the min and max of the charts to refresh everyone's memory. We are going to continue to focus on the L glass density, where we can see we have a minimum load PSI of 10, represented by the red line on the chart, as well as a maximum of 50 PSI, represented by the green line on the chart. Looking at the KIP 22L and 33L, one having 4 square inches and one having 9 square inches, we can see that they are both 1 inch tall. And when receiving 10 PSI, they both deflect 0.13%, or 0.13 inches, which is 13%. And as well as when both of those isolators receive 50 PSI, they will deflect 0.27 inches. If you have any questions on the FF.210 sheet, I look forward to seeing your email and getting your questions addressed. Next, we're going to look at the chart FF216. This chart shows natural frequency for a 1 inch unloaded thickness. To find natural frequency for other thicknesses, refer to the highlighted section. These formulas can be used to determine the natural frequency of different thicknesses based upon the result of the 1 inch. For example, if we wanted to find the natural frequency of the 2 inch pad, we would take the result from the 1 inch and multiply it by 0.71. Again, we are going to focus on the L-type curve. We're going to zoom in on the highlighted section. We can see the L-type curve highlighted on the left. And on the right, again, I have included the min and max load for everyone's convenience. We can locate on the x-axis the PSI of 10, represented by the red line, as well as the 50 by the green line. From here, we will follow the results over to the y-axis. So we have 16 when receiving 10 PSI, and we have 15.3 when receiving 50 PSI. Again, these are all for 1 inch KIP pads only. To determine the natural frequency of other thicknesses, we would take those results and multiply them by the values shown on the right, dependent upon the thicknesses shown on the left. Any questions on FF.216? I will be more than happy to address your questions in a timely manner. I look forward to your email. Next, we have the chart FF.215. This chart shows the natural frequency for a 2 inch unloaded thickness. Again, we will focus on the highlighted area, focusing on the L curve. We can see that we have highlighted down on the lower right all the 2 inch tall isolators, locating the 10 PSI on the x-axis, as well as the 50 PSI. Following those over on the Y, we will see a value of 11.3 and a 10.8. This chart was created to represent the 2 inch natural frequency ranges. For 2 inch is a very common used height as well as 1 inch. Once again, as always, if you have any questions on any of these charts, I look forward to answering them. As always, it is important to be able to locate your local representative to gain knowledge about local installations as well as pricing. To find your local representative, under the Contact tab, click on Local Representative, Here you will be asked to enter the location of your project, city and state. Next, under Select Noise Control Types, select Floors, Ceilings, and Partitions, Create Quiet. Then, find Rep. You should see a pin drop at the location you have entered, and should pop up your local representative's information with company name, website, point of contact, phone number, and email address. As always, if you have any questions on this webinar, we are here to help. You can reach out to any of our team members at the following phone number with the extension of 752. Or you can email the team at arcsales@kineticsnoise.com. Thank you for joining us, and I look forward to seeing you on the next webinar.